Hello student, I hope you are enjoying my videos on stereochemistry, and today we are going to see the R and S configuration, which is very important in a stereochemistry. Let us see R and S configuration. So before that you need to understand the stereoisomer. They are broadly classified into, that is, a geometric isomer and optical isomer. And from this optical isomer we are dealing with the chiral carbon and chiral center. So it is a requirement for the optical isomer. So it may be the chiral carbon or the molecule, or you can say that the molecular chirality is necessary. Means the molecule must be a chiral. These two things are necessary. So these optical isomers that can be classified either by dextro and levo, or that can be classified on the basis of whether it is R and S. And for that reason this R and S is very important to understand. So this R and S is also known as a CIP configuration. So this CIP is a Kahn, Ilgold and Pilov. These are the three scientists who gives the actual, the name is given from the Fischer projection. The CIP gives the Fischer projection, as well as they invent the configuration of optical isomer, that is R and S. So here the meaning of R is called as a rectus, that is called as a right hand side, or it is called as clockwise, and S means sinister, means left hand side, or you can say that anti-clockwise. So what is this means a level clockwise means what and anti-clockwise means what? These are the actually priorities. These priorities are given by these three scientists. So how to assign these priorities? There are certain rules to determine what is the configuration of given isomer, that is R or S. So here let us see one example. So here it is OH group, H, CH3 and COOH. So this is an example of a lactic acid. So what is the conformation of this lactic acid structure? So first of all, if you see the structure of lactic acid, so this lactic acid structure is represented in a Fischer projection. It means that this center carbon is not represented, it is represented by A2 lines. That two lines that intercept at a carbon, and this carbon is denoted by this intercept. Second, this horizontal line, indicates the groups that are on front side, means the groups that comes towards the observer, and this vertical line indicates This line indicates the groups are on backside. So this is very important to understand. That is the number one. What are the groups and the position of the groups, whether they are present in a vertical line or horizontal line. So here these carboxylic acid, it represents, it is on front side, and this CH3 is on front side. This hydrogen and this OH group that are on back side. So this is the first understanding when we look at a structure to assign RNS configuration. So what is the importance to understand which group is on the front side or which group is on back side? Because in RNS, rule number 1 is to assign priorities. So these priorities are according to their atomic number. The atom which is directly attached to the chiral carbon should have a first priority, and then later on subsequent next. Second, if once we apply the priority to the atom or group, then it is necessary to check whether the lowest priority group is on back side, that is on vertical side. Once you apply the priority, these priority rules are same as we are using in E and Z nomenclature, but here we have to use, we must have the lowest priority group on back side. That's why it is very necessary. What is the meaning of this vertical line? So here, now let us see one example. So here it is H, CH3, COOH and OH. That is the structure of lactic acid. So let us assign the priorities. We know that the priorities should be assigned according to the atomic number, as we learn in E and Z nomenclature. So here this oxygen is directly attached to the chiral carbon. So that's why this oxygen carries priority number 1. Then this carboxylic group will carry priority number 2. Then this methyl group carries third priority, and this hydrogen carries fourth priority. So once we assign the priorities, it is very necessary to check whether the lowest priority group is on vertical line or it should be on back side. So here the vertical line represent the hydrogen which is on back side, that must be considered to be a back side. So let us see the rotation, that is priority number 1, 2 and 3. So this rotation from 1, 2 and 3, so it rotates anti-clockwise. What we did, first we assigned the priorities. After that we identified whether the lowest priority group is on vertical line, whether it is the top or bottom of the line, that represent the back side of the structure. And then third we check the rotation. So here 1, 2 and 3. So this rotates anti-clockwise. That's why this structure will have S conformation. So this is a S configuration, that is the correct answer for this structure. So this is the basic about the RNS configuration. So let us see few more examples. So third rule is what? If the lowest priority group is not at the bottom or top or is not present at the vertical line, then what should we do? So it is important to do the interchange of the pair. So let us see. So here it is OH, H, CS3 and COOH. So if we want to assign the RNS, then we must go for assigning the priorities according to the atomic number. So the atomic number, so it carries number 1, so number 2 and number 3 and number 4. But the lowest priority group, that is fourth one, hydrogen, is not at a vertical line, then what should we do? So the third rule states that we should interchange. So what do we interchange? So we interchange the pair so that the lowest priority group should come on vertical line. So let us do the interchange. So here, if you want to interchange, then you want to interchange two pairs simultaneously. So if we do like this, then the configuration will not be changed. That's why it is advised that you should interchange two pairs. So let us see with the example. So here it is 1, 2, 3 and 4. So we are going to interchange first with the methyl group and first with the second. That is, we will interchange the OH with COH group, then hydrogen with methyl group. Then let us see case number 1. CH3, H, COOH and OH. Now this lowest priority group is on vertical line. So now we can assign the priorities and check their direction. So here 1, 2, 3 and 4. So the structure is rotating like this 1, 2, 3. It means that the conformation is S. That is anti-clockwise rotation is there. That's why we are assigning that it is S configuration. So you may think that what happen if this hydrogen we move towards the vertical line top. So let us see the case number 2, that is interchange this hydrogen with OH group so that it will go on top. Then what will be the configuration? So let us see with this red line. So now here it is a so here it is a hydrogen, then OH, then here it is COOH and CH3. So hydrogen now it is on the top. In the previous case it was at bottom. So we perform two kinds of interchange to check whether the answer remains same or get changed. So this OH will carry first priority, COH will be the second, CS3 will be the third and this will be the fourth. So now 1, 2, 3, look at this rotation. So this rotation is anti-clockwise, means the answer is yes. So from this we conclude that if the lowest priority group, if it is not at a vertical line, means if it is not at a back side, then we have to perform the interchange. If we perform the interchange, then this interchange may be of two types. You may perform either this lowest priority group on the top, or the lowest priority group should be on bottom side. So we perform these two cases, these two operations. So in that first one, we put this hydrogen, that is lowest priority group, on the bottom, and in this case this lowest priority group was at the top side. So from this we conclude that the answer remains change. So interchange is important, but interchange of two pair is important simultaneously. That's why the answer will not be changed. So this was the example that indicates what we do if the lowest priority group is not at the bottom or top. So in the next example, so interchange was there. So third was the interchange of the pair, and now the fourth one is what to do if we have a molecule having more than one stereo center. So molecules with more than one stereo center. So how to assign these RNAs for the molecule having more than one stereo center? So let us see one example. So here it is OH, CH3, CH3, OH, H and H. Now it is a molecule containing, this is one stereo center and this another one is a stereo center. So in this case it is very similar that to assign the priorities, that is this oxygen will carry first priority because this oxygen is directly attached to this chiral carbon. This oxygen is directly attached to this chiral carbon, so it carries number one priority. Now this remaining group is carries now this is one group, this one is another group and this one is another group. Now oxygen will carry first priority, then this remaining group will carry second priority, this methyl group carries third priority and this will carry fourth priority. So the lowest priority group should be on vertical line. It is not necessary in the case where there are more than one stereo center. So here the priority number 1, 2 and 3. So the rotation is goes like this, 1, 2 and 3. So it looks like as a S configuration. But what is important to see, the assigning the RNA's configuration in a molecule containing more than one stereo center is to invert the configuration. Means if it is yes, then your correct answer will be the R. But in this case you have to see whether this molecule contain two or more stereo center. Only and only in this case you have to give the opposite answer to what you are going to see. So here it is 1, 2 and 3. So it rotates anti-clockwise. So the answer is yes, but actually the correct answer is R. So in examination you have to just write down the correct answer, that is this one. This R is the correct answer. Then let us see for the second part. So here this hydrogen, this OH is carries first priority, this remaining part is carries second priority, this methyl carries third priority. So the structure is rotating like 1, 2 and 3. So it looks like R, but the correct answer is yes. So what you understand from this example, if more than one stereo center is present, then you have to give the opposite configuration. That opposite configuration will be the correct answer. It means that in this example, what you understand? So let us see another example. H, CH3, COH, H, CH3, COH. So here priority goes to first to this carboxylic acid group, then this second will be this one, this part, then third will be this, and fourth will be this one. Then the rotation will be 1, 2 and 3. So it rotates yes, but the actual answer is R. So you have to give the opposite configuration. This opposite configuration will be the right answer. So here it is 1, this remaining part will be the 2, this will be the 3, and check the rotation. So 1, 2 and 3. So answer is yes. So rotation look like as a clockwise, but you have to give the opposite answer, that is yes. So this is all about the compounds containing more than one stereo center. We learn about the configurational isomerism. In that we assign the RNS configuration, and in that RNS configuration we look the rules, how to assign the priorities, then when to go for interchange, and what are the rules to assign the RNS configuration for the stereo center having more than one stereo center.